Assalamualaikum and greetings to the Lajak Laku top management. We are from Group 16, in charge with tablet named PIL Lajak Kuruih F. We'll explain the quality of tablet manufacturing and analyze the status of production of PIL Lajak Kuruih F in December 2020. My name is Muhammad Imanrullah bin HAPIZAL and I will confirm whether the tablet produced follows a certain normal distribution.
Okay, my name is Muhammad FAREEZ ALLANY bin ANUWAR, and I will observe, describe, and summarize the sample data F for Lajak Kuruih tablet produced in December 2020.
Okay, my name is Muhammad AIMAN bin JAFFAR, and I will comment the validity of the model and predict some of the tensile strength of the tablet.
Hi, I'm Muhammad MARZUQI Muhammad Tom. I'm going to discuss on significant difference of tablet weight in 3 different types of sheep.
We will start the presentation with my observation and summarization about the data F. As we know, the parameter that we observe from the production was the weight in milligram, relative density in percentage, tensile strength in megapascal, and production shift. For each category, they have their own data range and frequency. We will get much clearer picture of this data pattern in the other graphical format. For as you can see here, I have prepared 3 graphical format, which is the first one is the bar chart of weight distribution, whereas the x-axis was the rate in milligram and the y-axis is the frequency. As you can see here, the distribution fit the normal curve that shows a bell shape over here, and the second one is the scattered chart of tablet hardness. It was formed when we plot tensile strength in megapascal against relative density in percentage. The further explanation will be continued by AIMAN. And for the last one, pie chart of the production shift. As we can see here, the most production was occurred in the morning with 37% of it, and in the evening there is 34% of the production, and the night the least one with 29%. For more detail, I will continue to the numerical form. As we know, the FDA requirement was the mean. As we know, the FDA requirement for the weight of standard tablet produced was with mean 350 mg with standard deviation of 40 mg. I calculated for both overall sample data and sample data based on shift. For overall sample data, the mean was 349.33 mg with standard deviation of 14.68 mg. And as we can see here, I have determined which shift that produce more accurate production. Where is the in the evening? We can see here the weight mean in the evening was in the evening production was 349.94 milligram with the standard deviation of 15.09, which is the closest one to the FDA requirement. Okay, that's all for my observation and summarization. We shall continue to the next one. Thank you.
Okay, for the next topic, we see that the Food and Drug Administration or FDA authority requires that the weight of standard tablet produced by manufacturers should be normally distributed with a mean of 350 milligrams and a standard deviation of 14 milligrams. So how do we confirm that the Lajak Kuruih PIL F follows this normal distribution? So based on the data given, the sample size is 200. We can assume that X is the weight of tablets in milligram and the level of significance is 0.05 or 5%. The H0 is X follows the normal distribution. The H1 does not follow the normal distribution. We will reject H0 if chi test is bigger than the chi alpha V. Because of the sample size of the data is so big, we must first collect the data by creating a frequency table. So we use a range of 10 from 310 to 380. The frequency for each ranges is as follows. To find the Z value, we must use this formula, which is X minus the mean over the standard deviation. For example, 310 minus 350 over 14 will get negative 2.86, and we will repeat the process for all the probability. So from the Z value, we will get the probability value from the statistical table. Next, for the table of chi-square test, Pi is the probability that we already calculated here, Pi. And the OI is the frequency. EI is the N times the probability. N is the sample size with 200. So 200 times probability will get this value. However, the EI must not be less than 5. So in order to get a suitable value, these two values must be added to the third value. While the last value, which is also less than 5, must be added to this value. This is the same for the OI as well. So we will get a new OI and EI value, which is 17, 15, and 15.2720. Next, we will use this formula and then add up all of it to have the chi-test value. So the chi-test value for this is 2.4128. Next, we will find the chi-alpha V value. For this value, we must find alpha is level of significance or 0.05. And the V value. The V value, which is here, can be found using K minus P minus 1. The K value is the number of variables, which is 1, 2, 3, 4, 5, 6. So K is 6. P is the number of parameters to be estimated. But since we already know the mean and standard deviation, there are no parameters to be estimated. So P is 0. So minus 1, we get the value of 5. So the value of X alpha V will be here. Using the table, we will get 11.0705. Since the chi-test value is lower than the chi-alpha V value, we do not reject H0. We can conclude at 5% level of significance, the weight of standard tablets Lajak Laku tablets produced in December 2020, regardless of shift, follows the normal distribution with mean of 350 mg and standard deviation of 40 mg.
For the question C, we are going to use one-way ANUWAR. We must generate our hypothesis statement by letting morning is equal to 1, evening is equal to 2, night is equal to 3. Under the H null, mu1, mu2, mu3 are equal, while H1, mu_i is not equal to mu_j for at least one ij. Our decision rule is to reject H0 if F calculated is greater than F critical. After that, we have to determine all the parameters such as Ni, Yi, Y double dot, and our N capital. The count is represented as Ni, which is the sample size of each group, while the sum is represented as our Yi, which is the sum of data in each group. To gain the grand total, Y double dot, just simply add these three values. For our N capital is going to be 200. Next, we must calculate our SSTRT, treatment sum square, SSE, error sum square, and lastly SST, total of sum square. We can gain this value by using the formula given in statistical table page 3. Next, for the degree of freedom, 2 is gained when k minus 1. We notice that k is equal to 3. When 3 minus 1 can get 2. For the total degree of freedom, just simply minus n capital with 1, then we can get 199. For the error degree of freedom, we need to minus 199 with 2. For the mean square, we just simply divide the sum square with each corresponding degree of freedom. Then we can get mean square treatment MSTRT, mean square error MSE. Then we can calculate the F calculated by divide the MSTRT with MSE. We notice that the F calculated is less than F critical. So we can conclude that at alpha equal to 0.05 level of significance, that there is no significant different tablet weight from different shifts.
Bismillahirrahmanirrahim. Thank you for the previous presenter. Now, I would like to discuss about the tablet hardness. Okay, tablet hardness can be explained by two variables. First is the relative density and another one is the tensile strength. Okay, based on the studies, it showed that relative density is the independent variable while the tensile strength is the dependent variable. Then, we will use Microsoft Excel to perform simple linear regression, and the result will be like this. To confirm that we insert the correct value or not, first we look at the observation, and you can see it is 200, same with the sample size. Then we can see the estimated intercept is 0.216 and the estimated slope is 0.0782. We can see the regression equation will be like this: y equal to 0.2617 plus 0.07821x. The interpretation can be made that a unit increase in x lead to 0.07821 increase in y. Directly from the Excel, we can get the value of the correlation coefficient, that is 0.8447, and the value is near to 1, the unity, and we can conclude it formed a strong positive linear relationship between relative density and tensile strength. Also, from this data, we can check the confidence interval for the relative density. The 95% of confidence interval is 0.07126 and 0.085159. By using hypothesis test, we can test the significance of regression where relative density is different from 0. Using F-test approach, we will say that H0 is relative density equal to 0 and H1 is the relative density beta is not equal to 0. We will reject H0 if the p-value or significant F is less than alpha. In this case, the alpha is 0.05. From this table, we can see that our significant F is 1.17252, E negative 55. So, compared to the alpha 0.05, we see the significant F or p-value is smaller than alpha, so we will reject H0. This concludes that the data provide a strong evidence that linear significance exists between x and y. Next, we will see the normal probability plot. As you can see, the data are randomly sketched along the straight line, so we can say that the normal assumption is satisfied. Next, we will see the relative density residual plot. As you can see here, all the residual is sketched around 0. This indicates that the normal assumption is satisfied. Lastly, we will see the relative density line fit plot. As you can see, all the blue dot is the observed data, while the orange dot is the predicted tensile strength. We can say that this model is valid because it is positive linear, same with the hypothesis test that we have confirmed. So that's all from me. Thank you. Okay, this concludes our meeting for today. If you have any further information or question, you can meet us. Thank you for listening.